And if you're joining us here in Prague in the room, if you wouldn't mind signing into the blue sheets which are circulating. And thanks for coming on a Friday morning at 9 o'clock. For those of you online and also in the room, you'll see the note well. Please take a look at that online. It's also indicated on the blue sheets that this is part of what we do here at the IETF. We make sure that people are aware of what the policies are.
Sorry, Jane, could you hear me?
Yes, we can.
I send you some final corrections of my presentation.
It's uploaded. It should be. I uploaded it this morning.
Yes, but I just send it another one. Do you have time to change it? Will be fine. But
I'm kind of here alone, so no. But I'll upload it after if you don't mind.
Okay.
Okay, thanks.
Jane?
Yes?
This is Julian.
Hi, Julian. I did see your slides. I'm going to try and upload them. Okay? Go ahead.
I sent a presentation in PDF.
See. I have it. And I'll try and upload it now. Give me 1 second.
Okay. Thank you.
So for those of you in the room, give me about 2 minutes. And thank you for joining. We're going to start in about a minute. I'm just uploading some more slides. And we're going to start with Michuki Mwangi. Michuki is from Kenya and works for the Internet Society. He'll do an introduction about peering and interconnection in sub-Saharan Africa, where he's done more to help provide connectivity than just about anybody I know. So give it 1 minute as I upload the other slides. Okay, if you're in the room, you're at Gaia, Global Access to the Internet for All. Our charter is online. You can take a look. Otherwise, a lot of what we do here is bring in presentations from people who are either building connectivity, new innovative tech solutions around the world. We've been focused mostly on community networks over the last 3 or 4 meetings, but we're bringing in more and more on we're going to be bringing in more and more on internet exchange points, routing, data collection. So today the first person up is Michuki, and I did see him on Meet Echo. Michuki, you're up first, and I'm going to show your slides here in the room, and hopefully we can see you in a minute. So over to you, Michuki.
Thank you, Jen. Good morning, everyone. It's a pleasure to be here at Gaia today and present. The title of my presentation here this morning is Developing Peering and Interconnection Through Partnerships in Africa, and basically just shows an overview of what we've been able to do in Africa. While I've been at the Internet Society for the last 10 years, working in internet development and also promoting interconnection and traffic exchange. And part of the success that we've seen in the past 10 years is largely due to the support we've had from partners through partnerships and collaboration. So I'll start off with a bit of a background in terms of where all this started. I joined the Internet Society in 2008, and I was at the time also working with the Kenya Internet Exchange Point. So next slide, Jane. And during that time, we wanted to get involved. There was an interest from the Internet Society to work on Internet exchange points, but there wasn't a clear understanding of what was really happening in the region. So the first thing we did is did a survey of the exchange points that were in place and tried to understand what was really going on. So at the time, there were about 17 IXPs in 15 African countries. And we tried to send a survey to each one of them and get some feedback. And about 12 were actually responsive after a lot of nagging and probing. But we did get some data, like, when they were established, how much traffic they had, how they were operating in terms of their governance, what kind of peering policy they had, and so on. And this survey that we did in 2008 has actually been used as a benchmark to start off or to rather build on to the work that we've done over the years. And FIX has been maintaining the surveys to date, the most recent being in 2017. And we'll have a look at that data later on in my presentation. We also see, if you're seeing the presentation on the diagram, that at that time there were only 2 submarine cables in Africa, mostly on the West African side of the continent, and the CMIV3, which goes on to Asia. So next slide, Jane. So one of the things which was interesting to identify at that point in time was that based on the responses we received, there was just about 300 Mbps or megabits per second being exchanged through the IXPs in Africa, which was quite small. And so, and a couple of the other gaps we identified, if you could go, oh, sorry, and before I move on, and majority of this traffic was actually in South Africa, with all the other exchange points in the continent being relatively small. Next slide, please, Jane. So the gaps we identified from this survey was that there was a lack of general knowledge on IXP best practices. IXPs didn't know where to go in terms of sharing experiences on how to grow and develop. So they were pretty much operating in a silo. There was almost no interconnection between cross borders of various countries. So packets between one country to the other in Africa all had to go through Europe. We didn't understand why some of the IXPs weren't responsive. And as you saw in the initial map that I showed, West Africa was pretty much lagging behind with respect to IXPs. And essentially, if you look at the data with only 300 megabits per second compared to how much Africa was importing at the time, there was what we termed then as an internet transit deficit, which in comparison to other regions was quite huge. So the next slide. So we opted to start the work, and to start the work, we wanted to identify how do we actually scope out what we need to do and have an impact. And the first thing we went ahead to do, next slide, is to map out the partners or whom we need to work out with, to partner with and collaborate with to be able to create an impact. And so we did an exercise where we mapped out what we call the spheres of influence and identified the policymakers, the operators and service providers, the IXPs and the technical community as part of the ecosystem that we needed to engage with in developing peering and interconnection in Africa. Next slide, please. And in so doing, we were able now to start mapping out how we'll work with those partners to do work when it came to issues of like technical and best practice workshops for countries that either didn't have IXPs or had IXPs but didn't have the training, where there were new IXPs expected, and help them set up, be it equipment, be it actual setup. We did provide technical assistance as well, and also held IXP meetings. And 2 years later into the work, around 2010, we launched the African Peering and Interconnection Forum, where we were bringing together the operators, the service providers, the policymakers, IXPs to talk about peering. And, like at that particular meeting, we'll start the event with what we call the peering game, which basically help people have a better understanding of what peering and interconnection was all about. So if you go to the next slide, we had, during this period between 2008 and 2019, we were able to cover quite a lot of ground. We've been able to organize 9 AFPIF events, so this year will be the 10-year anniversary. And over this period, we've had over 50 organizations supporting the AFPIF events. We've done workshops in 22 countries, and this is excluding the work we did with the African Union on Axis, which I'll talk about shortly after. Trained over 500 engineers, supported the setup of the AFIX Association, or which is the African IXP Association. We've partnered with organizations like Cisco, Google, and Facebook to provide equipment and technical assistance to more than 20 IXPs. We've engaged policymakers to make sure that the issues of IXPs are brought to the attention of policymakers and support their setup and creation. We've done studies that have been used to reinforce our messaging on the importance and value and benefit of IXPs, and worked with organizations like Testbook, the IXPN in Nigeria, Rwanda, and Akamai, among others. And of course, one of the things which we've also been able to do is develop a tool that enables us to keep measuring what we are doing and see whether there is actually any impact or growth over the same period. And basically, as a result, the ecosystem has evolved. We are seeing new data centers coming up there in the region. There's been policy review in favor of IXPs and so on. And as a result of the work that we did, if you look at the next slide, you will see that we were able to implement, or we were able to successfully bid and implement the African Union project called Access. And that helped us do a total of about 63 workshops within a period of 2 years. Basically created a new partnership between the African Union and the Internet Society and the technical community. We covered 28 countries in the continent with the workshops, went to most of them twice. As a result, there have been 10 new IXPs, more than at least 10 new IXPs that have been set up. Support of 8 IXPs to grow into regional IXPs. And of course, an increased awareness. If you come to Africa, not just policymakers, but decision makers are well aware about IXPs and the value that they bring. So, and also another important issue here is also the issue of cross-border, and we've seen that that has also had an impact. So if you look at the next slide, I did mention about AFPIF, and one of the things I wanted to mention about the success of AFPIF is that our ability to partner and collaborate has actually yielded more than 50 organizations supporting the event. If you look at this this banner, rather, this is just AFPIF last year. We had more than 30 sponsors coming to the event and supporting organizations and so on. So, and this is just 1 year, and we've been on for the last 9. So it's a great success in my view, and basically a clear indicator that to have an impact, collaboration and partnership is key. So what are the outcomes? And very quickly before I run out of time, so the first outcome was that there was an accepted vision for Africa, where 80% of the traffic there is a vision to reverse that internet transit deficit, where 80% of the traffic is expected to be locally accessible and only 20% international by the year 2020. Now, this may sound ambitious, has sounded ambitious, but a couple of years ago, we had networks saying that they have reached 70-30 and they will get there before the year 2020. If you look at the next slide, you will see also we've had more than 44 IXPs. So this is a huge growth, over 100% growth since 2008. Traffic has grown significantly. More than 400 gig of traffic is being exchanged. And West Africa doesn't look like, sorry. I had a timer. There's been a lot of IXPs emerging in the west and north part of the continent. So I'll just quickly go through the next set of slides because I think I have about two minutes left. So the growth in the continent has been significant in terms of the traffic, as you can see. So this is data that FIX maintains with respect to using the baseline that we did in 2008. The next slide, you will see that we've had traffic growing very fast, over 400 gig now. Next slide, you'll see that the number of networks has also increased from slightly under 200, or rather 150 to more than 866 networks connected. And the tool that we developed for measurements called ARDA actually helps us see how networks are connected both at the national level. You are able to see what percentage of the networks of ASNs in a particular country are connecting to a particular IX. Next slide, please. So looking at Benin, and then next slide, you will also be able to see what happens between cross-border. And this is an example of Tanzania, where you can see there is a huge number of Afrinic external to Tanzania, Afrinic ASNs or external to Tanzania that are connected or visible at the exchange point in Tanzania. So next slide, please. And the next one as well. So despite all of this, there's been a couple of challenges, and I think a lot of the challenges are quite what we found, with a couple of slight improvements. There are issues with terrestrial infrastructure. Carrier neutral data centers are not there. Cross-border is still not to the level where we'd like it to be. Next slide. And of course, the issue of managing stakeholder interest, because when governments do get involved, it does tend out to have create some problems. However, the work still continues, and basically, IXPs are operational, but they do face some challenges with respect to not having sustainable business models, where they have volunteer staff and being able to keep up with everything that's happening versus paid staff, and also issues of good governance and meeting their obligations. Next slide, please. So the work continues. Next. Next. Yes, so the work continues, and basically some of the work that we're going tends to address some of the challenges, and basically we would like to make sure that we support IXPs with the equipment, capacity building, new ones are supported, support the work that FIX is doing in bringing together the stakeholders, work on measurements to make sure that there is increasing data available to see where the gaps are and where more efforts need to be put in place, and also continuing to push on policy issues to address some of the pending issues on cross-border interconnection and terrestrial capacity availability across the continent. So one of the things that we are working on the next slide, is we have a new partnership that started last year with Facebook, and basically spans over 2 years, and it's going to cover or span across training and community mobilization, doing best practice workshops and technical aspects training, IXP infrastructure development, so we'll give equipment, switches, optical transceivers, and others for existing IXPs to upgrade and new ones that are coming up, and also help with the peering ecosystem development and the community of practice, which are the peering roadshows and AFPIF and so on. And then finally, one of the things which has been happening is the deployment of caches at IXPs. We've seen has been a challenge, and we have a process in place to help a couple of IXPs over the next 3 years to sort of help them implement caches at the exchange point that can be shared with all the stakeholders. So that sort of shows that the partnership is continuing. We've had relatively good success, and we continue to identify with partners and organizations that have an interest in developing the IXP and peering and interconnection ecosystem in Africa to improve that space. So I'd like to stop there, and thank you very much. Happy to take any questions. Sorry, Jane, I ran slightly over time.
Thank you, Michuki. Does anyone have any questions for Michuki in the room or online? Okay, I see no one in the room. Michuki, thank you very much. The slides are uploaded into the Gaia deck. And yep, there's some very interesting comments. Thank you very much, Michuki, from some of the people in the Jabber chat. And for those of you that had heard Michuki talk about the African Peering and Interconnection Forum that happens in August 20th through 22nd, it's really been an amazing event to watch the number of networks coming in, the content delivery, and general operators, but people, everything from submarine cable operators to terrestrial fiber providers attend those meetings to talk about building the African internet. So thank you very much, Machuki. If anyone has any other questions, Machuki's reachable. I think his email's in the presentation. And thank you very much. So the next person up is Miriam Kune from RIPE, a sister organization of many of ours. And she's going to talk about RIPE tools.
Thank you, Jane. Do you want me to click? That was amazing progress. I remember the early days, and Michuki and all his colleagues have done a tremendous job there. Now to something completely different. Some of you might be familiar with this. I'm just going to do it's a bit of a mixed bag of certain tools and data sets that might be relevant and that are all available and publicly accessible. So it might be interesting for researchers, but also operators. And some of them also help to measure this kind of progress that Michuki has shown. Well, I'm not going to talk about what the RIRs do. I think most of you will know this. The yellow bit there is our service region, so it's quite large, and there are 5 of us worldwide, and we all do slightly different activities. And so the RIPE NCC has originally started out as a community secretariat, so as a secretariat for the RIPE community, and maybe that's also why we're doing a bit more maybe than the other areas as in community work and developing tools and measurements and data and statistics, and doing a lot of community building as well. So to dive right into RIPE Atlas, I think also maybe most of you are familiar with this. How many of you have a RIPE Atlas probe at home? All right, yes. Good. I didn't bring any, but we have a new version. I'll talk about it in a second. So it basically is a distributed measurement network that does active measurements of network, not traffic, but delays basically. So I'll get to that. So we have over 10,000 of them available. We just came out with a new version 4. It's this one. It's a bit more stable than the old one, has more memory, and it's kind of a little bit better. We also have these called RIPE Atlas anchors. They're just kind of mega probes. They have more memory and can do more measurements, and they can also use as targets for other probes. And we're covering over 180 countries at the moment with those probes. You saw the map earlier on. And we're still working on expanding the reach, like of the topology. So you can see we're currently covering 3,600 IPv4 ASs and about 1,500 IPv6 ASs. So there's still some work to do because there are a lot more out there. And so we're now starting to actively distribute these new probes. And as I said, all the data is publicly available. And I believe I have a link here on this slide at the bottom. You can find statistics, you can find APIs, and graphics and everything. And so it does what these little devices do. Basically, you plug them in your router at home or in your network somewhere, and they do active measurements, and they're listed there, like ping, trace, route, DNS, SSL, NTP, and to a certain extent HTTP. And I could do a whole different presentation about the whole ethical background of these measurements, which are actually really interesting, but I'm not going to do that now. Because HTTP measurements was a huge discussion, and some people wanted us to enable them, but there is also a certain risk associated with that because you can use other people's probes to initiate measurements, and HTTP measurements in some countries, or certain websites in some countries, just aren't, are illegal. And so we only enabled HTTP measurements towards these mega probes, these anchors. And so the hosts of these anchors, they are aware of this, and they accept that. There are APIs, there are visualizations, there are also some command line tools, and you can stream real-life data. There's a lot of data out there at the moment. Also, you can run your own measurements, but it's always worth looking if somebody else has already done a similar measurement that you can just reuse. And a new thing I wanted to mention here, so there's a whole lot of people have come up with the greatest use cases that we have never foreseen for Web Atlas, and there's a lot of use cases and statistics and graphics published already on the Web Labs blog that we're running. This is a relatively new thing I wanted to show you because it shows kind of a nice overview of countries' infrastructure. So we kind of gone back to end-to-end measurements. So there's a lot of client to server measurements out there because that's what people do to improve traffic and cost optimization. And so we looked at peer-to-peer and serverless connections and came up with this. There's a link here. You can go there. I think the link on the slides are all interactive, so you can click on them. And then you get something like, well, I'll get to that. This tool is based on Web Atlas, but also on APNIX data, their population data that they publish. And it's based on Web Atlas and another tool that kind of measures the IXPs, traffic that goes through IXPs. That's also an interesting tool. It's linked there. And all that together, we come up with something like this. So this is just an example. This is Belgium, and you probably can't read all the descriptions there, but what you basically see is the main service providers in that country, or the main network in that country, and only those networks that have more than 1% user base in that particular country. And so we only look at, when I say country, there's like Atlas probes in that country, right? And the population data that APNIC provides. And so the larger the ring is that you can see, the larger the segment of the ring, the larger the network. And then you have these little dots in there in the ring, that's the end users. And so we basically measure one Atlas probe to another Atlas probe, and then the path that these trace routes kind of do. And so you can see in the middle, for instance, here is an orange like ring, that's an exchange point. So you can see some traffic goes through an exchange point. The blue rings are transit providers, and there are also some direct, not in this case, I think some direct links. And then if you go to the website, it's interactive. You can go onto the link and it gives you some more, you can go onto these graphs and it gives you some more information about each of the networks. And I'm just going to flip through some countries because you can see quite nicely the kind of the network ecosystem in a country. And you can also, if you go on the website, you can see change the timeline. So you can go back in time. And it's amazing how this changes. It's not very stable, actually. You know? So from month to month, you see traffic going through exchange points. Then the exchange point disappears. It comes back. So it's quite interesting. This is the US, for instance. You see a lot of little networks there. So I said only the networks that have more than 1% users. So the gap there is all the other networks that we didn't even take into account. So there are a lot more networks in there. So that's a very meshed kind of network in the US. A lot of transit providers, a lot of exchange points. So that's kind of one extreme, if you will. There are others that are much more clean, like the Germans. So this one is has a lot, like Deutsche Telekom is a big one, and there are like 3 or so exchange points that a lot of traffic goes through, and it's quite a stable network there. This is Slovakia. I thought we're close by, so I'll show that. Most of the traffic there goes through exchange points. So you don't see any transit providers. So it's all exchange point based or direct through network, like one network to another. So that's another interesting example. Right. So you can go to the website and play with that. Look at your country, see how the situation is at the moment. It's still a prototype, so there are a lot of caveats. But if you see anything that looks weird, please contact us and we'll investigate. Another relatively new thing we did is geolocation for infrastructure. It's also based on Web Atlas. And so and we're crowdsourcing that. So we're using some of the Web Atlas data, but also other data sources that we kind of put together in one tool. And then we calculate the average and publish that. And there's a labs article about that, how we actually do that. And it kind of looks like this. So you can fill in, this is the interface if you go to the website, and fill in a in this case, I put an M6 just to show, and it finds the location, and then it measures trace routes. For instance, you can see visualization there, how traffic goes from one thing to the other. And just I want to stress that this is infrastructure, so it's like servers that basically that we find in the trace routes. It's not end user geolocation. Another set of tools that we provide, or another tool that's probably familiar to most of you, I think Michuki mentioned route views, and this is another one, the routing information service that the RIPE NCC has been running for, I don't know, 20 years or so. It basically is a network of BGP route collectors, like worldwide, and it collects a lot of data. So it has over 18 years or maybe 20 years of routing history, but by now it's used a lot by researchers and operators, and has a number of peers. So there's a map, I think, where all the route collectors are at the moment, and it has a lot of different access possibilities. You can get the raw data. You can also use BGP dump, and there is and then you can get through it to RIPEStat. RIPEStat is a tool. I didn't put a link in there. I think I have a slide on that later on. RIPEStat is kind of a graphical interface where you can also access all the data sets that I'm presenting here. And this is a new thing we started, we announced a few weeks ago. It's a live stream based on risk data, and that's been received very well in the community because that makes it much easier to monitor changes in a routing system. And it's just a screenshot of an example there. It's all just explained in that RIPE Labs article. And finally, all this is in the RIPEStat interface that I just mentioned. It looks like this. This is a graphical interface. You can put in an IP address or an AS number or a domain name or a country code also. And then it kind of spits out a bunch of measurements that we have based on that resource. And so it has a default view where you can see is the AS number, for instance, in this case, is it announced? Where is it located? And then you can dive into the little menus on the left-hand side. You can see a lot about the routing or geolocation or DNS. We also have some information about abuse and blacklists. And then you can get also the raw data for each of those widgets. We have the raw data available. So these are the data sets that are currently available through RIPEStat. As I said, all the main data sets that we collect ourselves. Obviously, the IP registry data from us and the other RIRs. Also, RIPERIS is in there, RIPE Atlas data, and a bunch of external data sets, and they're listed here. So it gives quite an interesting overview of a certain, of a specific resource that you can look up there. There are over 50 widgets at the moment, and you can embed them on your own website. You use them for monitoring or alerts, and there is a lot of documentation and an API and raw data, everything there. Yeah, I'm not going to go through all the use cases. There's just some examples here. And I think that's it. That's the last slide with a bunch of references. You can look them up. Some of them are kind of in prototype, like the IXP country JEDI and the user-to-user measurements I mentioned earlier. You can play with the interface there and let us know what you think. I think that's it. I had one more slide. I didn't put that in. No, I just wanted to mention that a lot of this, and you heard me say this, is documented on labs.ripe.net, the RIPE Labs blog that we maintain. And there is a lot of information, a lot of use cases, and we're also always open. If you find a new use case, or if you're working on something interesting, interesting research project, we are happy to publish that there. That's it. And I'll be back on time.
You are way on time.
I'm
Thank
sorry.
you.
Are there any questions?
Any questions for Miriam? Yes, good.
Hi, this is Luis Contreras from Telefónica. Due that the most of the traffic nowadays is basically video in the network, maybe around 60-70% of the traffic is video. Have you considered to implement a kind of test for measuring this? Maybe for well-accepted video, YouTube or something like that?
You said HTTP traffic.
Yes.
Yeah. I'm not sure if you have a specific visualization on that, because as I said earlier, we only allow HTTP measurements towards these anchors, and we have about 400 of them in the network, so it's not that many. But I'm not aware that we actually look specifically at that, but it's a good point. We could we could do that. I know that like Wikimedia and also other content providers have used Web Atlas to look at the placement of their CDNs basically. So that's one thing, but that's more like content. But it has, of course, HTTP in there, but I don't know if we have specifically looked at that. But it's a good suggestion. Thanks.
Thank you.
Okay. Runa Barik from University of Oslo. So how do you handle the set of IPs, those from the terrestrial data? Those are not resolved by IP to ASN or by root view or by looking to the bogons, and they are not owned by any ISP. How do you handle those rest of the IPs, which are publicly reachable?
So are you asking about the Web Atlas measurements specifically?
No, the set of IPs that you could see in the trace route. Yeah, maybe you might see in the trace route from Web Atlas. Yeah.
Yeah, in the trace. Yeah. So we basically look at the trace route in the from one Atlas probe to another, and that's all we measure basically.
So in between the trace route, the routers addresses, how do you resolve them? Because I don't find any ISP that they own those IPs.
I'm not sure we analyzed that.
Okay. Because you presented the AS diagram, and then because these are the ASS, those whose IPs are resolved to those ASS, but the rest of the IPs I'm asking.
Well, they're all announced, so we look at the trace route. Let's take that offline. I'm not sure exactly. I know what you mean. Okay.
Thank you for your question. Yeah, that was a good one. And if you can speak right into the microphone, because it's hard to hear sometimes.
Okay, can you hear me now?
Yes.
Okay.
Hi, David.
Yeah, I have one question and one comment. My question is, what is the coverage of the Atlas probes? Do you have now? I remember in the old days, you are pushing for to put more and more. So if do you need still some help so that we promote them in the regions, and how? My second information I have to say is you were talking about use cases that you didn't think about, and there is one funny one. It's about me. My connection is often off. So before going home to make sure if I have, for example, a meeting and I'm somewhere else, I check on the probe if it is on or off before going home. Otherwise, I will go and use a connection somewhere else. So this is an advantage.
That's great to hear. That's great. That's a very legitimate use case. I know people also use it basically to check if the power is still on in their house when they're on travel and they have like a vacation home somewhere remote, because it'll give you a warning if the probe is off. Apparently, maybe the power is off as well, right? But to your first question, yes, we definitely need better coverage, specifically outside Europe. So we are still very much interested in you helping out with distributing the probes, and I know ISOC is helping a lot distributing them, Afrinic and other RIRs. We had a bit of a gap now because we just came out with these new probes, but we are back on the game now, so we are definitely interested in covering and distributing more probes. So thanks for your help. I know you are helping out a lot.
Hi, Miriam. Brooks Schofield from Jount. What was the name of that service that does the magic circle diagrams?
I'm not sure it has a real name yet. This is the one, right?
I found it, but I really like it.
Oh, thank you.
And so obviously the grey, obviously anyone who pops up grey there, they have 0 probes in their AS.
Good point.
So that's a good way of...
That's a good point, because I looked through some of the countries and I didn't use them as an example because there are a lot of gray areas in there where we don't have any probes. And then that's a good indication of countries that actually need more probes for us to do proper measurements. Yeah, good point.
Especially for the large ISPs.
Exactly.
We should do something for the R&E networks that looks like this to see how they're interconnected And that might be useful for looking at R&E networks in Africa and whether they're using IXPs or whether they have to transit everything back to Europe to get connectivity.
Yeah, happy to collaborate there, Brooke.
Yeah. I know how to get in contact with you. And
Great, thanks. That's a good suggestion.
I don't see anything in the Jabber chat other than thank you. Any other questions for Miriam? You know how to reach her, and the Probe project is amazing, and huge supporters of it, and we love the new graphics.
Thank you. Yeah, I had some contact points on the last slide, but you've probably seen them.
Perfect.
So, okay, thank you.
Thank you, everyone. Okay, the next person up is Xavi, and Xavi, we're going to pull your slides up. If you want to introduce yourself, we will pull the slides up and let you have at it.
Hi, could you hear me?
We can hear you. Go ahead.
Okay, good morning, everyone. I'm Xavi Poza from Barcelona. We work in a small ISP based on fiber and wireless networks. We deliver services to the end users and also for administration, also for public companies. And we are based on Giphy.net Foundation, so all of our network that we are building is based on common networks and can be used by other operators that joins Giphy.net Foundation. So today we want to talk about the fiber optic external plan, or the best practices for start a project of own fiber. And we can see all the steps about the process in between. So first of all, we need to plan the global feasibility of the project. This is a huge work because we need to think about all the aspects related. Then we will have the next step about technical feasibilities. The cable could be tied. We need to see also some legal aspects in the countries. The different countries, the legal is different. We need to produce a network design just to have a good planification. Then we have the cable tie. It's a dirty job, as I always see. Also, which electronics we will deploy in the network, and considerations about the final or the consequent maintenance that the network have to be. So next, we can see the feasibility of the project, which characteristics we need to have in present. And the first is the CapEx available. And for calculate the CapEx, one of the most important thing is if we have civil work needed to deploy the fiber. So this is the most expensive part of the project. And if we can plan before that, it will help us to have a very close number to the final price of the deployment. Also, we need to have to plan is the transport availability. We will do via radio or via fiber optic. It depends on the remotely zone if it's connected or not. So we can plan also wireless links to have a transport link to the main point of presence. We need to talk about the OPEX, the maintenance cost, because we will have then to maintenance this network. It's not only need to start, we need to calculate the transport services, what's the cost of that, the maintenance that it will have. It will constitute like an operator or an association. It then will have administrative aspects to be considered. And also, if we will have expenses about the infrastructure If we are renting towers or renting some conduits to other operators, then we need to consider also. Technical feasibility means that we need to plan from where pass the cable. As you can see in the picture, there is from Barcelona. You can see 4 operators that have deployed the fiber in the front of the building. Also, you can see the box of the copper cables. Also, you can observe that the fiber optics are not empty, are not full, sorry. So we need to plan also the capacity of the network before, because if not, we are getting into extra cost that maybe we don't want to have at the beginning. We need to consider here if the owner wants to have the cable in their or under the window, so keep the aspect in a good way. Let's see the next about the conduits. Through the way of pass the fiber, we will have enough space, because sometimes all the conduits are full and it will complicate a lot the fiber, the complete project, only for one part of the way. So that's very, very important to have a very nice vision of all the way where we will pass the cable. Also, the poles. The poles are normally owned in Spain by Telefónica, so we need to talk with them and have a pre-planification, because sometimes the poles are very old, or maybe if we add some cables to the pole, the tension that it has needs to change the pole by another one bigger or made by another material. So it's very, very important thing to be considered also. For planning those things, we have access to the Movistar database, where we can see the canalizations, the current conducts, and have an idea if we are talking about X meters of conducted cables, or if we need to pass some poles or walls and follow the path that normally is designed by Movistar. This is not mandatory, but it's very, very recommended to have the plan in the middle. Also, for rent this kind of conduit that owns the operator, here in Spain we have to talk with Movistar, and the CNMC forces Movistar to rent his conduits. So we need to talk about with them, plan a consequent planification of the tie, and of course, if we need to have change, then replan again the problem. But for now, it's available in Spain through the website. So that's the replanning that we need to do. You can see in the picture a replacement of one pole that we need to change it by another bigger and stronger. And also maybe the conduits inside this second picture. If this is full, then we need to construct another one, or maybe we need to try another way. There are other systems that we have used in the past, maybe passing the cable through the conduits of water. This is a very new implementation. It's not cheap, but it has a very good results, because we can pass the fiber between, put a conduit first inside the tube, and then pass the fiber inside the conduit. And it can be done in a long, very distances. So it's a very, very interesting thing to be considered. Then we need to locate where the connections will will aggregate. And it's called a data center. It can be inside a municipality building, or maybe if they have one close, we need to construct a box outdoor. And that's an example of one of that we did. It's a very small stuff, so it can be very, very deployed fastly, and it has a very good result. So is the project viable? Then we need to prepare the documentation to start. We need to do a draft of the project, of the deployment plan, and then follow the next steps. One of the most important things is the legal aspects. So if we are now sure that we can pass the fiber, let's see if the law is allowing us to do. And then we need to ask each participant in between or deployment if we can pass the fiber over there. So first, we need to submit a deployment plan, document what is the design of the network to the administrative. They have some time to answer. If they don't answer in a lot of months, then the answer is yes. So we can go ahead. The project for municipalities sometimes is repeated because there are technical aspects that they want to know, of course. If they have infrastructure in the towns, they need to know from where are passing and have all of them documented. So it's very important if the municipality requires perform a project with all the technical aspects. Also, as I say, the permissions can be from the municipalities, from the general administration, maybe for larger infrastructure operators, the train or highway operators, but also can be done by particular owners that can give us the permission to pass the fiber. And also the permissions related to the Marco, to the process of ask Movistar about the conducts is performed by fundaciogifi.net, that it managed this way. The network design that we show is a GPON typical implementation. We need to design this because there are limitations about the distance and number of these devices connected to them. Also, we need to cover some areas that are very, very full and other ones that are very empty, like industrial areas. Sometimes they have only few. So we need to plan that arm of the network from where it's coming and how many fibers we will have. Also, we need to calculate in the network design all the power loss that we have in between the passive elements. The GPON deployment does not need from power source in the elements that are in between. So it's a very good advantage. Also, the fiber cable has a very low loss, and also the splicers are very, very, very low in the loss. Where we found the most of the loss is in the splitter. Is where we separate the fiber in order to have a lot of customers connected in one single fiber. As you see, the level of split is increasing a lot. The loss passive of all the link. So we need to take it very, very, very care about that. Also, for performance network design, it's very helpful to have some tools that can help us to make draws and to plan the cable, the poles. Each element in the network needs to be represented in the design, because then we can find some troubles, some problems, and we can separate them and make it easy the solution. So it's a very important thing. In Giphy.net, we have Fiberfi, that is an open source network deployed by some of the IT guys inside. We are very proud of that tool because now it has a new interface, and it's very, very easy to use. It has requires very high skills, and it's a very good tool. Let's go with the cable deployment. That's the dirty job that I said. It needs to be done by very strong people because working on outdoors is very, very hard. We have the sun, we have the rain, we have the cold. So we need to plan this with. My recommendation is to have a very close employees, not to use sub-rented ones, because then the cable is done not fine. It's bad done. So we prefer to work with very close people, also pay them well, because this part will perdure during the time, maybe 40, maybe 50 years. So that's a very important thing. So we need to dimension the fiber optic, how many fibers we need in the principal brand of the deployment, and how many fibers then we need to split in the final facilities. Let's go ahead with which system we will have inside the boxes. There are two main types, the pre-connectoring and the fused cable. Some of them have, as you see, the cost of the material of the pre-connector is higher, but it avoids one fusion, so it saves time. Maybe also it prevents the manipulation of the passive network because the box is always closed. Now, the technician needs only to connect one side and also go inside the facilities of the customer and then do a splice inside. By the other way, the fused cable has a very low cost material, but it needs two splices and requires the manipulation of the CTO. So be careful about that. It's cheaper, but the preferred for me is pre-connectoring. Also, we need a lot of tools for do the cable deployment. You will need a very big guide to pass through the longest conducts. Also, you will need a splicer that is not cheap. It's an expensive tool. You will need some signalization stuff and also other tools that maybe you will need or maybe not, depending on the area. Here, sometimes it rains a lot and all the conducts are full of water. So first we need to go with the water bomb and keep dry the conducts. Also, you need to take care about the loops. Leave some cable just for maintenance, or just if you need to change the pole, have the possibility to do it, not have a very short cable that it will not permit the work. Okay. The GPON electronics that we need to consider about the dimension, about the capacity. The prices are very, very, very cute. All of them have a very good price now, so that's not very expensive stuff. But maybe we need to dimension about the consume of the device, or maybe the number of end users that we will have in that zone. So it depends on it. We will have one on another. And the final step is to keep in mind the maintenance, because the network will need it for sure over the time. Optic fiber are very strong networks, very low incidence. So, and all of the incidents, the 80% of the incidents are in the households. So keep in mind, always have very good tools like the optical reflectometer that will keep us a complete vision of the path including all the fusions, all the connectors that are in between. So with that tool, we can see in a very fast way where to go to repair that problem. It's not a cheap one, so you will need to expand or maybe rent one to this is very important to have to consider it also. So thanks for giving me this chance to explain you the fiber optic paradigm. And if you have questions, please ask.
Any questions in the room for Xavi or online? Carlos, did you get your questions answered about the copper? I think yes. And there's a question for you, Xavi, from Machuki. Yeah. What vendors are you using for the GPN, ONT, and CPEs?
Yes, we are now using Huawei, but we have also used Telnet One, that is a Spanish brand, at the beginning of the deployments. Now for cost and because maybe everyone is going this way, we are using Huawei. Yeah.
Yeah, GPON, sorry about that.
What's the question of the copper? Sorry. Yes, I see. Very similar OFN copper boxes. Yes. In the photograph, it looks very similar. At the end, the fiber optic cables that we are using are very similar to the copper one. So expect the same density of cables, but by the way, the pre-connectoring increases a lot the space needed. So as you see, if in one box we have less connections than in copper, so expect more space to have the same connections.
And there's a note in the chat that there are some questions and suggestions in open discussion in the GuiFiNet community about the convenience of using Huawei products.
Yeah, I am also very afraid about that because there are recently rumors that are not good. But well, we have some research and security teams that are looking for that, working hard on that. Also, we have some distributors that are responsible of refirm the device. So put a firmware that we know that it's okay and it's original from the brand, and also we check after if the device are doing some bad things. We are scanning, we are doing a lot of research in that point, and for now we can be confident with that brand.
Okay, thank you very much, Xavi. We appreciate your presentation. We're going to hop over to Leandro now, but continue in the chat on Jabber because there are some other questions that people are asking.
Sure, I will.
And for folks in the room who don't know GuiFiNet, it's probably the largest community network in the world, at least over Xavi, over 150,000 users, right? In different places.
Yeah.
Okay. And there's plenty of information online too at guifi.net. So Leandro, we're going to queue up your slides, but you're up next, and I'll just ask the next three presenters. We have about 30 minutes, so I'm going to ask you to go pretty quickly if you can, and all your slides are uploaded, so it's just me creating the technical difficulty now and getting them up. So Leandro, you're up next.
Okay, thank you. I hope you hear me. Okay, so the objective of the presentation is to talk about one of the activities we can do in Gaia, which is about proposing raising information about best current practices on different aspects. So some years ago we had an effort in Gaia to document alternative ways other than the well-known to develop connectivity. And then, so maybe next slide. Yeah. It was RIC 7962 that covers different technologies in different cases. So things have changed significantly in some of the aspects of that document. And then the discussion was if we can think about doing a document to report some of the best current practices beyond the previous document. Next slide. So yeah, I started the idea of looking at particularly some developments which have changed in the last time, which is connected to the previous presentation. Is nowadays fiber has become more easy to deploy and more cost effective, and there are several examples of operators which are not the typical commercial operators, but that can find and succeed in delivering high-speed broadband connections in communities that otherwise doesn't seem to be the target of commercial deployments. And then, of course, every case is like complex and particular, and the idea is to understand what are the mechanisms to do it, what are the environmental factors to allow that, to facilitate replication, especially in underserved areas or as alternative to other options. And next slide. So there are several cases that match this idea of gigabit fiber networks, and there are, as I said, technology allows, but the difficulty many times is about the huge investment required to do that. That can be probably more easily done by a centralized entity like an operator, but which is difficult in cases where the operator doesn't have an incentive to do it or is not interested because it's not profitable, but is socially profitable for the community to have it. There are, initial investments, maintenance costs, the problem of return of investment, and also the risk in any long-term investment. And well, in the end, is this idea of allowing building your own connectivity, which has appeared many times in the Gaia context. Next slide. So, with a few people started a survey to collect information about some cases which deserve attention as potential candidates to this best current practice on optical alternative networks. And then we were starting to collect information about where they are, what is their financing and investment model, how they are organized legally, what is their economic model, the governance, things related to license, stakeholders, regulation in that particular place, incentives which enable or disable the development of these networks. What are the differences and savings compared to a commercial model? And also an important factor seems to be the existence or not of universal service fund programs and how they are implemented and what effect they have in large that we know, but also in small operators. And well, this is the idea of the survey. In the next slide, you will see, I think, one picture of the live spreadsheet we are sharing to collect this information. And then, for instance, we collected details from one optical network that runs in the UK. It's called BARN. We also analyzed one optical network among the several in the Giffynet ecosystem, and one that is different from Chavi's one, and one fiber network in the US in Vermont. And so this is an ongoing process. So next slide. So the objective of this presentation is to collect ideas about how the idea might make sense, how to structure the document, how to collect details, and and see if this is a kind of reasonable, useful update over the previous RFC document that was produced in the working group. And I think that's all. I think probably this. My email contact is at the end, so I'm looking forward to hear your comments or live or maybe by email about how we can develop that document. Thank you.
Thank you, Leandro. And Leandro is the co-chair of Gaia with me, and what he's talking about is a great doc that we could hack together on best current practices. And a lot of the community networks or local access networks that are being built from the communities out, or the village or the town, the region, are these small networks that, well, not so small if you're talking about Guifi, and now there's been a lot of publicity recently in the media about community networks because of the lack of access in a lot of rural, remote, and even urban areas. And so you've got the data there for Leandro, and we'll be bringing this back up on the Gaia list throughout the next months until we meet up again in Montreal. So if you want to give some information to Leandro, that would be excellent. And so any questions in the room? I don't see any. Anything else in the Jabber chat? I think, Leandro, you can answer there. And we're going to hop over to our colleague Julian Casasbuenas from Colnodo, which is affiliated with APC, a great project that does lots of great different work, but also specifically on community networks. And so we're going to bring up your presentation, Julian. Give us 2 seconds.
Thank you.
Ready.
Thank you, Jane. Thank you for the invitation. I would like to share with all of you this experience that we developed in Colombia, in the southern part of the country. It's called Buenos Aires, Cauca. Basically what we want to set up there, it's a cellular network and internet network as a social program handled by the community. Next, please. So what's our definition of a community network? It's that connects rural communities at affordable cost. It's owned by the community, and it is in charge of the community itself, of its implementation, operation, and management. And the difference between community network and a commercial network, next please, could be represent here. The community owns the local network, while the commercial operator owns the network. The community design, builds, and defines how the network will operate. This is digital autonomy, while the commercial operator is the one who designs, builds, and defines the way in which the network will operate. The community network defines the fees it will set for its affiliate, while the commercial operator is the one who defines the price that will charge. Community networks are non-for-profit, while the commercial operator seeks to obtain the greatest possible utility. Revenues are applied in the improvement of the network, innovation, training, and remains owned by the community, while the revenues are applied to network maintenance and utilities for business owners. And community owns the operation along with other communities that be a part of an association, and the operator owns the operation of leases and concession to other operators. So that's the comparison between the two models. Next, please. So what's the what we are offering with these initiatives? The cellular network will provide unlimited calls within the network or community networks. and unlimited local messages, SMS. And we will handle the long distance and international calls through the voice over IP. So, and also the network is providing internet connectivity, provide internet connection and internal network services. We set up internet network, and we want to see how difficult it is in Colombia to interconnect the fiber optic that reaches most of the municipalities and was deployed during the past government. And but it's still very expensive to connect these fiber optics to the rural areas. But that's in terms of technical terms, is the best option that we have to reach rural communities with the best internet connection and more stable. But as I mentioned, it's still very expensive. Please, next. So how does it work, this initiative? Each community is organized to install, operate, and administer its own cell phone network and or internet. An organization associates communities to strengthen the networks. Allied organizations provide technological, legal, technical, and administrative advice. This is our partner in Mexico, Rizomatica. It's providing all the support for the cellular network. The Association for Progressive Communication supports for appropriation of technology with a gender focus. So we reach gender group, women in the area of the project. Internet Society is providing support as well, and University of Cauca and WorldCom. So it's very important that it's a branch of organizations that are supporting the project to different aspects of it. The community administers its network. They cover maintenance fees and receives advice, training, and reports for testing the services and for evolution and improvement of the network. Next, please. The technology we are using for the mobile network is based on radio bases, BTS, and control station equipment. We are using Osmocom and OpenBSD, which is a free software that emulates the component of the cellular network. And it's the one that Rizomatica has been developing. And it can handle up to 14 to 28 simultaneous calls for a perimeter of about 5 to 8 kilometers. And it's intended to serve about 400 to 450 users. Next, please. This is the expected coverage that we have in the network. As I mentioned, is located in Buenos Aires, Cauca. It's like a south west of the country. Next, please. And we have been supporting a community to get organized and administer the system through a community operator. And each network has a person that administers it and one that supports the operation and maintenance. That's the model that we want to implement. Next, please. What we would like to prove with this pilot is demonstrate that with new technical, organizational, and economic scheme, it is possible to provide cellular telephony service in a community and in a sustainable way, and that the community is able to contribute with organizational structure, physical facilities, maintenance of the network, And also we are providing legal support and technical support. So we would like to prove that the community is able to run their own networks. Next, please. It's important to mention that we have been, since the beginning and the signing of the project, the participation of the community. They also identify this kind of uses for the network, for protection of the community, to alert in case of emergencies, to convene and inform the community, to have better internal communications within the community, and also to contact and communicate with family contacts and other communities. Next, please. Also important to mention that the community has been very active in all the process of the installation, as you can see in these slides. Next, please. And well, we have the setup already. This is part of the installation that we did. And in some cases, we are using solar panels to provide power to the equipment. Next, please. And this resumes what we have done so far. And we did in the first stage, the identification of the communities. We wanted to reach a community that it's isolated in rural areas with very little connectivity. And Buenos Aires, Cauca, it's one of the zones where ex-combatants of the guerrilla movement FARC that signed the peace agreement are located. So it has been an important place to do this pilot. We did the planning with the community, as mentioned. We did the installation already. And we are working with the political and regulatory matters because in Colombia, we cannot use the mobile spectrum that is required. So we are negotiating with the Ministry of ICTs and the Nation Agency of Spectrum in do this pilot to prove that this kind of projects can be implemented. And we are in the way to sign an agreement that will allow us to use the spectrum and run the pilot, and to prove their sustainability and involvement of the community. Next, please. Maybe mention also that we have been negotiating for about 2 years now. And well, it has been difficult, but we expect that we will be able to have the permission to run the pilot with the equipment for mobile communications. So this has been working also in the characterization of the communities, and we run digital literacy workshops and also train them in marketing, educational resources, security, and networks. Next, please. So maybe finalizing, saying that this has been a project with a permanent participation of the community, and we are willing that this can be proved that it's a model that can be sustainable, not only in financial terms, but also in social terms. So that's it. Thank you.
Thank you, Julian. Any questions in the room for Julian? This is an amazing project, and as he was saying, the issues with spectrum are difficult in many places. You've got the will and the energy and the technical equipment and the wherewithal, but then you can get hung up in using spectrum that's actually available, but you don't have the authorization to use.
Yes, at this moment, we are not allowed to use the range of a spectrum that we want to use. Even if it's free at this moment, it's not used by any operator, and it's a very tiny range of a spectrum. But we are discussing at this moment with the government the implementation of a new law of ICTs that new government want to present to the Congress, and we want community networks to be recognized as an alternative for connectivity in rural areas where no connectivity is available for them, but especially to have access to the spectrum and deploy these kind of networks and initiatives.
Thank you, Julian. I know how hard you've been working on this, and Colombia has a really good spectrum ministry and a great ministry of communications. So thank you for interfacing with them. I think what you're doing is actually leading the way for so many others. I'm going to carve into your coffee break for about 2 to 3 minutes and give you a flavor for a project that will also have Nico Pache from Altermundi, who's also working now with APC. We're going to hop over to Nico for a minute. I'm going to give you the access, Nico. And if you could take 2 or 3 minutes, and then we'll wrap up, just because everybody here probably wants a coffee. But what we're going to do is also have Nico jump in first in the meeting in Montreal. So Nico, we're going to pull up your slides.
Thank you, Jane, and hi to everyone. Thank you, Jane and Leandro, for facilitating the space. I am Nico Pache. I am part of APC, the Association for Progressive Communications. For those that have not heard about APC, you can put the next slide. APC is an international network dedicated to empowering and supporting groups and individuals working for peace, human rights, development, protection of the environment. We use ICTs, and we have been in this space for about 30 years. APC has been doing access projects has been involved in access and connectivity in rural and in developing countries for many years. So next slide, please. Last year, APC has run a project that was called Can Them Connect, Connect Themselves. It was a project funded by IDRC that was run together with Rhizomatica and in very close collaboration with Internet Society that looked to research a little bit in regards to this question, and the outcomes of this research have been many, and they will be announced very soon at the WCIS forum next month. And well, they have been. There are reports in relation to the gender implications within community networks, the technical and business models that the existing community networks are using, and also APC in collaboration with ISOC have released some papers in relation to spectrum and the typification of community networks in regulations and many other contributions along the way. Next slide. So with the output of this initial research project, it gave us information that was extremely valuable for us to continue to see what to do in the next steps. And what the research group discovered was that there were existing communities that would be very important to support. And by supporting the communities that were already running, it would be an approach to grow the community network world as a whole. Next slide. So the project has identified 5 areas in which we will be working to support community networks in their process, and so grow the community network arena. The first one is about strengthening the community network movement. in order to do that, 12 community networks from Latin America, Asia, and Africa will be supported to learn from each other. And in order to do that, so they have been already identified, and I am glad to say that Colnodo from Colombia is one of the communities that will be part of this 9 months program. And the program will focus on strengthening the capabilities of the existing community networks, such as, all of those capabilities that are weak, we will focus on helping them achieve, to be more robust, and all of those strengths that they already have, we will support them in sharing those with their peers. That will happen through peer exchanges, so the community networks will be able to visit each other, to learn from each other. We will encourage them to produce materials that they can use, and many new communities can use to share knowledge with each other. And also, there's going to be a set of workshops in relation to technologies, methods, and models. And probably, well, not probably, part of it will be used to build a syllabus where that new community networks will be able to use to build their own. The next part will be the awareness raising. No, please, previous one. The awareness raising and movement building. So we don't only, we saw that part of the growth of the movement happens in this space where they get together. So we will support community networks in exchanging knowledge, not only with each other, but also in conferences. So we will support them in participating at national and regional events, and leveling them up in a way, like helping them be facilitators of spaces. Next slide. Then there is the supportive innovative technology, and I think this is very interesting for all of you. We have a set of Pathfinder grants, they are called. The purpose of the Pathfinder grants is for the community networks to be able to innovate in technologies or or policy or regulation innovations that can help them go one leap forward, and this will be bottom-up innovation. So it will be by them, and them being the center of the technology innovation. Next slide. Then there's a part in relation to policy and regulation. So in this context, regulation and policy, as Julian shared with us, it can be challenging, and frequencies might not be available for community networks, or the legal framework might not be the most viable for communities to be able to thrive. So there's going to be a lot of work in relation to helping make a legal framework that is viable for them in relation to doing training workshops with regulators, engaging in policy events, and also creating capacity within the communities to do so. Next slide. And this last aspect, that is the gender perspective, is intersectional, and it's across all the activities that we will be doing. And it's about having a gender perspective in relation to everything that we do and everything that we approach. So creating equal opportunities and for everyone within the community network movement. Next one. So I will leave you with a link of the project where everything is going to be published along the way. Next one. If you have any questions about the presentations, just don't hesitate to send them. Thank you.
Thank you, Nico. And Nico was here a couple IETFs ago talking about Libra Router, which is open source mesh networking and servers. So he also can give you some great data on that type of work. But Nico, thank you. And I think any questions for Nico? It's a coffee break, Nico, so sorry. People are headed out. But I will say this, that you're going to be up first in Montreal, and we'll be looking forward to hearing more about how the project is going. APC is a huge partner of many of ours who are on this, in the presenters here today, and a key partner for a lot of local connectivity and development. And if you haven't signed the blue sheets, please do that. But we'd like to thank everybody who participated today. Michuki, Miriam, Chavi, Leandro, Julian, and Nico, thank you very much. And we look forward to seeing you guys in Montreal. And check us out on Gaia for the BCP that Leandro has started, and we can all add to it. Thanks so much, and appreciate your time, and have a good day. So thank you to everybody. Really great presentations. And keep up the good work to connect people who are unconnected. Thank you. Thank you. All right, guys, we're going to shut down the Jabber chat. Thank you very much.
Thank you. Bye.